1. And then remember, you guys have a ton of extra practice problems posted on Polaris, 3 of each of these, plus I'll put whatever questions the other classes picked today on there as well. So lots of extra things to look over tonight as you're studying. All right, so first problem says to condense. We're condensing a log. Addition changes to multiplication. Subtraction changes to division. And if we have anything multiplied in front of our log, we can move it up into the exponents, are the steps that we're going to follow here. So go ahead and pick a number. What do we like? 47. Okay, so we are going to condense 2 natural log x minus 1/2 natural log x squared plus 1. Okay, so as you're condensing, the first thing that you're going to do is if you have a number in front, you're going to move it up into the exponent. So if I move a 2 up into the exponent for that first term, it's going to become an x squared. And then if I move a 1/2 up into the exponent, a 1/2 power is the same as what? Square root. So it's going to be natural log square root x squared plus 1. Okay, so I have no more numbers out front. They're going to become exponents. I don't have any addition in this problem. I have addition inside the log, but not between the logs, so we don't do anything with that. And then I have subtraction between the logs. Subtraction between the logs turns into division. X squared, or anything that's a positive term in general, is going to go in the numerator. Square root x squared plus 1, or anything that's a negative term, is going to go in the denominator. And then you can kind of run through the checklist one more time. We have a single log really at the end, though, with nothing in front of it, so that's a quick way to tell that you're condensed completely. This is really like the ultimate goal. You want to get as few logs as possible. We've written it as 1 log, so we're good. Okay. Questions condensing. Okay, expanding is just the opposite then, and that's the next problem. Pick a number. I'll write it a little bigger for you then. What do we want to expand? 38. Pick the big one. All right, so I have natural log. Move it up a little bit for me here. There we go. Of x plus 1 to the 1/2 power. X squared minus 2 to the 2/5 power. 2x minus 1 to the 3/2 power, and x squared plus 2 to the negative 4/5 power. Okay. So opposite now, if I have division, it's going to change to subtraction. If I have multiplication, it's going to change to addition. And if I have any exponents, I want to move them down in front. The steps here are going to be the opposite of what we did. The last thing we did in the previous problem was we changed it to division. So the first thing we're going to do is change the division to subtraction. So it's going to be natural log of whatever's in that numerator, x plus 1 to the 1/2, x squared minus 2 to the 2/5, minus natural log 2x minus 1 to the 3/2, x squared plus 2 to the negative 4/5. Okay, so my fraction became 2 natural logs that are subtracted. So the next thing I want to look for is multiplication. I do have multiplication inside my logs, inside both of them. Multiplication is going to turn into addition. So I'm going to have natural log x plus 1 to the 1/2 plus, notice everything's a natural log. That's never going to change, whatever log base you start with. Natural log x squared minus 2 to the 2/5. There we go. Now be careful on this next little group here. That minus is going to apply to both natural logs that we're going to create. So I'm going to put a bracket there. Natural log 2x minus 1 to the 3/2 plus natural log x squared plus 2 to the negative 4/5. Okay, so division inside my log turned to subtraction. Multiplication inside my log turned to addition. The last thing that we can do is if we have any exponents, we can move them down in front of their respective logs, and each of these has an exponent. So it's going to be 1/2 natural log x plus 1 plus 2/5 natural log x squared minus 2. You can either distribute the negative through here if you want to. Let's call it an optional step, or you can just leave it. I'm just going to leave it. 3/2 natural log 2x minus 1. And if I bring a negative 4/5 down in front of that last term, it's going to be a minus 4/5 natural log x squared plus 2. And again, the only other thing you could do, optional step, is distribute the negative through, but that doesn't make it more or less expanded, which is the goal of this problem. So you can stop there. So then just run through the checklist again. No division inside my logs, no multiplication inside my logs, and then no more powers. I do have multiplication with like the 2 and the x and that third log, but that minus 1 prevents me from doing anything else with it. Okay. Questions on that one? Okay. Third one you're going to see tomorrow is where you're given a bunch of information. Like here we're given log of x is 2, log of y is 3, log of 2 is about 0.3, and log of 3 is about 0.48. We want to use that information to evaluate a log. So go ahead and pick one of them that's here. Any number will do. $15. Okay, so I have log cube root x squared y to the 4th. Okay, if you guys remember doing this in class, the kind of hidden instructions to this problem are expand it completely first. The most common mistake that is made in this problem is it is not expanded completely before people try to substitute things in from that given information. The very absolute last thing you should do in this problem is touch that given information at the top. Okay, so if I'm going to expand this completely, I first want to think about that cube root is the same as what exponent? Well, square root's a 1/2 power, right? What's a cube root? 1/3. Okay, and if I have a power, where can I put it? Down in front. 1/3. Log of x squared y to the 4th. Am I expanded completely? What else can I do? Okay, multiplication is going to turn into what? Addition. And don't forget that 1/3 is going to apply to everything, so I'm going to add a bracket here. It's going to be log of x squared plus log of y to the 4th. Am I expanded completely now? Yes or no? No? What can you still do? Exponents down in front of their respective log. So it's going to be 2 log x plus 4 log y. All right, am I expanded completely now? Okay, yeah, I don't have any division, multiplication inside my logs, and I don't have any powers. So that's how I know I've expanded completely. Now we look at the given information. What is log of x equal to at the top there? 2. And what is log of y equal to at the top there? 3. And then this is just something you can type in your calculator. Remember, tomorrow you can use your graphing calculator. You'll have it. So let's see. I've got 2 times 2 plus 4 times 3. So that's 4 and 12 in the middle. That gives me 16 times 1/3. Exact answer at the end is going to be 16/3. Okay. Questions on the third one, number 13. Okay, next up, this problem, you're gonna maybe see it on the extra review online because we did it last year. We did not cover this year. So number 14, not something you have to worry about, ignore it, okay? All right, number 15, write how many digits this number has and then put it in scientific notation. This is one of those really big number problems that we did in class. Pick a problem. Any will do. 51. Okay, and if you remember in class, I'll just do the same thing we did in the notes. We called it a K, that number. Okay, if you try to type this in your calculator, it's going to give you that overflow error. So what we did was we took the log of both sides to start. Taking the log allows me to do what? Exponent down in front, using that rule again, that power rule. 756 times log 324. Bless you. Now you can use your calculator. And again, you'll have the graphing calculator. All right, so type it in, 756 log 324, and every digit is important here. So every number you see in the calculator, write it down. 1897.972028 you should get. Do you remember what you do with that number to figure out how many digits our number has? How we round it? Which way do we round, up or down? Round up. If I round up, this number has 1898 digits. Okay, so that answers the first part of the question. How many digits are there? Second part of the question is now we want to put this in scientific notation. This log is what log base? 10, okay, and I have a log that's alone. So what do you do with it? What's the next step? Right, with exponents, WWE. What's the base? 10. My power is that big number, 1897.972028 equals K. So now my number is written as a power of 10. And then what we did with this is we split it into two pieces. 10 to a power times 10 to a power, where those powers are going to add up to my original exponent, the 1897 point whatever. The whole number is going to go on the right, and the decimal, 0.972028, is going to go on the left. 10 to the 1897, that's what scientific notation is going to look like, right? 10 to a integer power to a whole number power. And then this piece is what you can type in your calculator to get the number in front, whatever between 1 and 10 that you have. So 10 to the 0.972028. And again, just give it all the decimal places you can because it's such a big number, it's going to be rounded a lot anyway. 4557. And that's our number in scientific notation, which you can see then that makes sense. We would have 800 or 1,898 digits because that decimal is really 1,897 units to the right hands. Yes?
So as an exponent, when you write 1897, not 1898?
Right. Yes, you're just using the exact decimal that you see there, exact number. You never round down for this. Always round up. It's part of the theorem. Hold that thought. Hi, that's Miss McDonald. Hey. She is in the TLC making a test. Okay. She probably will be, I guess. Okay. Bye. Okay. Other questions? Okay. All right. Now, maybe that wants to move. There we go. All right. So now we're going to get into our formulas that we need to know. This one has to do with money that needs to grow to a certain amount. So pick a problem, then we'll kind of walk through it. 95 through 98. What looks good? 96. Okay. So this problem says, how long will it take to grow your investment from 10,000 to 120,000 at a rate of 10% if it's compounded semi-annually? The fact that it's compounded semi-annually is enough to tell you which formula you are using. Does anybody know what formula we're going to use if we're compounded any other way other than continuously? Really? It's just the general compound interest formula, which you need to know. Okay. P is the initial amount, your initial investment. R is your interest rate as a decimal. N is how many times it's compounded per year. T is the time in years. A is what you end with. So where does 10,000 go? P. Where does 120,000 go? That's A. What's my R? 10% as a decimal is 0.10 or just 0.1. N is how many times we compound per year. So if it's semi-annually, what number do we use? 2. If it's annually, what number do you use? Quarterly? Monthly? Okay. 2 times, and then T is what we're solving for here, right? Got it. How long will it take? All right, so how do I solve for T? What would be your first step? What are we going to do? It's an exponential equation. You solved these yesterday on your test, right? You had a base to a power. There's something in front of it. So what do you do with that something in front? Divide it in this case, move it to the other side. We want to get the exponent base alone. Just like if we're solving a log equation, we want to get the log alone. All right, so we're dividing by 10,000 on each side, which is just going to give me 12 equals 1 plus 0.10 over 2 to the 2t power. Okay, now I've got my exponent base, this guy, alone. What do you do next? What'd you do yesterday on your test? Got the base alone and then did what? Take the log. Log 12 equals log of all this other stuff. 1 plus 0.10 over 2 to the 2t power. And because I put a log there, what does that allow me to do? Move the exponent down. Take the log, move the exponent down. So 2t times log 1 plus 0.10 over 2. And now it looks a little messy with the logs, but remember log 12 and log of 1 plus 0.1 over 2, those are just numbers. You can figure out what they are in your calculator. So I'm going to divide by this log first, just to get it over there. So that'll leave me with 2t on the right, and then all that stuff's going to be stuff you're going to put in your graphing calculator. I get 50.93. Divide by 2, you get your answer. So T is 25.46. So to the nearest year, if it asks for that, you could say 25 years, or you could just say 25.4, actually 47 if I rounded 2 decimal places. 47 years. Okay. If you want to check it, just like the equations from yesterday, take it, plug it back in the equation, make sure it works. We rounded a little bit, so it's going to be approximate, but you should get about 120,000 when you plug it back in, which should only take a minute with your graphing calculator to do. So definitely worth your time if you can. All right, next problem. We're going to have a half-life problem. So you need to know your half-life formulas. Pick a number. 92. Okay. 2 half-life formulas you need to know. H equals negative natural log 2 over K, where H is the half-life of some element and K is the rate of decay. The other formula is, it's basically like our PERT formula, A sub 0 e to the kt power. So A sub 0 is your starting amount, A of t is your ending amount, E of course is E, K is that growth rate again, T is time in years. K, remember, will always be a negative number in these problems because it is always exponential decay when we're talking about our half-life. All right, so in this problem, it says plutonium-241 has a half-life of 13 years. That's my H. 13 equals negative natural log 2 over K. A lab purchased 10 grams of the substance but did not use it for 2 years. How much of the substance was left after 2 years? So where does 10 go? Ten's the starting amount. And then 2 years is how much time has gone by. So that's our T. Okay, times 2. a of t, how much is left, is what we're solving for in this problem. Now, depending on what you're given, you'll start with one side of this or the other. In this case, I'm able to solve for k on the left side. K is the only variable that's left in that half-life equation. So I'm going to multiply by k to get it out of the denominator first, and then I'm going to divide by 13. Negative natural log 2 divided by 13 gives me negative 0.0533. That's my k value. Once you know k in one of the equations, you can plug it into the other equation to find what you're missing. So I'm going to plug it into that a of t formula. A of t equals 10 e negative 0.0533 times 2, and all of that you can type in your calculator. Nothing we have to solve for on this one. And I get, if I give it 2 decimal places, 8.99, and everything's measured in grams here. 8.99 grams of the material remains. Okay. Questions on 17. All right, we got 2 more. Number 18. We have got a problem where we are finding the principal, finding the initial investment that's going to generate a future value. So pick a number, 73, 4, 5, 6, or 88. What do we like? 75. Okay. So we've got 10,000 at 8% compounded daily for 10 years. We are again using our general compound interest formula here. If it said compounded continuously, what formula is that? PERT. So make sure you write that down. That could pop up in a problem. If it's compounded continuously, you use PERT. Any other time, we use this one. All right, so A is 10,000. We're solving for the principal, what we're going to start with. Interest rate, 0.08. Compounded daily, what do we use for daily? 365. And then that shows up in my exponent again, 365 times number of years, 10. Now, if you're solving for P, P is multiplied by this stuff, right? That number to a power, whatever it is, which you could type in your calculator and get that number. So let's say we know what that number is. What do we do with it to solve for P? How do I get the P alone? Just divide it over. So this is really just stuff you're going to do in the calculator at this point. Type that value to a power in, and then divide it over to the other side to solve for P. And P is what we start with. We know we ended with 10,000, so we should expect something smaller than 10,000. So let's see. 1 plus 0.08 over 365 to the 365 times 10 power. This is like 2.225-ish. You really don't have to round it, though, because then in your calculator you can do 10,000 divided by that previous answer. And then this you should be able to get to the penny then, 4493.68. Which then, if you want, you can take that, plug it in for P, and make sure you get approximately 10,000. Okay. Questions on 18? All right, last one then, number 19, is just back to our transformation rules. Again, we originally did these in section 2.7. That's where the big chart with the A, B, C, D was. If you need to look back at those to study. So we've got e to the x here that has been transformed. We want to name the transformations on the graph of the function. Pick a number. 83. Okay. So I have f of x equals negative e to the x minus 2 power plus 3. So a couple things we looked at when we did these transformation rules originally. Remember that there should never be anything in front of your x, and if there is something in front of the x, you want it factored away from the x. Like if I had a 2 here, I would factor a 2. It would still be in the parentheses, but I would put 2 in front of this with the parentheses. And then if sometimes like this problem, for example, that vertical shift is in the front, it's maybe a little easier to see it if you write it in the back instead. A little more easy to identify it. But this one looks like it's in a good form. What does that negative out front do? Over. Yep. If you have a negative out front, it's a reflection over the x-axis. If you have a negative in front of the x, inside the exponent, that would be a reflection over the y-axis. I have a -2 inside the exponent, so that means inside the function. Whenever you have a -2 in the function, what does it do? Right, 2. If it was a plus, move it to the left. And then finally, we have a +3 at the end, which moves us up 3. Okay, so that's a set of questions you're going to see tomorrow. Make sure you know your formulas. Again, number 14, if you see that on any of the review online, I think I made a note to cross it out. I tried to take it out where I could. You don't have to worry about that problem. It's got a bunch of like logs and systems of equations. And then there will be a bonus tomorrow as well. Question? Yes, so I just recorded, that'll be our video, and then I'll post this, and then the other class periods as well. But you've also, in the meantime, if you want to like study today during the day, you've got all the extra practice problems that are already on there, just like usual. Could you show what it looks like with the reflection on the y-axis? Yep, if I had a reflection over the y-axis, actually, let me do this one, because that one's a little out of order there. So I've got e to the 2 minus x. I would write it -x plus 2 instead, because usually we see the number after the x, and then plus 3. That's equivalent. But I have a negative in front of the x. You can't have anything in front of that x if you want to use those transformation rules, so I would factor it out, and it would look like this. So this would be almost exactly the same as what we have. I have a -2, which moves it right 2. A +3, which moves it up 3, and then that negative, because it's in front of the x, and the exponent would be a reflection over the y-axis. No graphing tomorrow. Nope. Just one of each of these. Anything else? All right, so you guys have like 15 minutes now. If you want to look over some of that extra stuff that's on there, I'll do the cell phone lotto tomorrow, part 2 graphing calculator, and then we're just going to start getting ready for the final exam.